The objective of this video is to practice reactions in aqueous solution, mainly acid-base reactions. So we are going to practice writing equations and learn what these acid-base reactions are. So acids. Acids are basically the substances that will produce an H plus when you try to dissolve it in water. The substances, when we put them in water that dissolves H plus, are called as acids. So all of this list shows you acids. You can see that hydrogen has been highlighted, mentioned in red color. So when we dissolve any of these given substances, they will release an H plus. So that means if you put HF into water, it will break down as H plus and fluoride ion. If we put hydrochloric acid, HCl, it will break down as H plus and chloride minus. If we put acetic acid into water, it will break down as H plus and C2H3O2 minus. So see the charge neutrality. The number of H pluses separated matches how much negative charge you should have. For example, if you have sulfuric acid, it can give 2H plus and matches with the sulfate charge. And then bases are compounds that can generally give OH minus. See a list of common hydroxides or bases you can use. So that means if you write a formula as a hydroxide, anything ending with hydroxide can act as a base. Now you know hydroxide is a polyatomic ion, it's an oxyanion. So hydroxides are in general their bases, while these acids, they're starting with hydrogen in the beginning. So acids give H pluses and bases generally give OH minus. So this is one way we identify acids or bases based on whether they are giving H plus or OH minus. Acids break down to give H plus and hydroxide or these bases break down to give OH minus. Now what happens when we mix an acid with a base? We call them as neutralization reactions. Why? We have this H plus coming from the acid and OH minus coming from the base. The opposites attract. H plus combine with OH minus and form water. And if you notice the previous equation, in the acids, it's not just H that is coming from the acid, we have this anion as well. Some sort of an anion. It can be a chloride, it can be a nitrate or an acetate. And then when it went from the hydroxide or the base, it's not just OH, there is a cation also coming like sodium or potassium, some sort of a metal ion, a positive charge. So the positive charge of the base and the negative charge of the acid will come together and make a salt. So what is this salt? It is not necessarily sodium chloride. A salt means an ionic compound. Any ionic compound can be considered as a salt. So in this equation, what we mean as a salt is the ionic compound or the ionic species that result from the spectator ions. This salt is a result of the spectator ions. So let's look into some examples of acid-base reactions. We have the acid and the base, and see what happens. You are making a salt. the positive end of one species combined with the negative end of the other species, and what happened to the remaining ones. The same pattern. So this represents a double displacement reaction. So that means the neutralization reactions are actually double displacement reactions. All these species, you can break them down based on the solubility guidelines that you already know. Chlorides. Chlorides are in general, they're soluble, few exceptions. Hydrogen is not the exception. So HCl is soluble in water. Sodium hydroxide. Sodium is a group 1 substance, so it is always soluble in water. Then sodium chloride, again group 1, always soluble, so you have aqueous. And every time we make water, usually if we find it in liquid state, usually we find it in liquid state at room temperature, so we put the symbol L for pure water. Now this is the molecular equation for this acid-base reaction. Why you can find all species in the molecular form, you don't see any charges. However, in the second equation, you can find things in the ionized form. So everything that is coming with the AQ symbol, you can break it down into ions. So what you see in the second equation is the complete ionic equation. HCl can be broken down into H plus, Cl minus. Sodium hydroxide, you have AQ, so you can break it down to sodium plus, OH minus. You have sodium chloride with AQ, so you can break it down into AQ and sodium plus AQ and Cl minus AQ. However, water is in the liquid form. That means it's existing as a purely covalent compound. So we are not going to break this down because we don't have the AQ form. So once you remove the spectator ions, what are the spectator ions? You have sodium and chlorine. These two are the spectator ions, in this case forming this salt. This is your net ionic equation. Now go ahead and write the equations for this given reaction between nitric acid and lithium hydroxide. Alright. So for this second equation, recall that these are double displacement reactions. All acid-base reactions are going to be double displacement reaction. So you're simply displacing each other's partner. Nitrate will pair up with lithium and hydrogen will pair up with this OH. Hydrogen pairing up with OH result in water molecule, and then other pairing up you result in lithium nitrate. Now think about the solubility rules. Lithium nitrate, is it water soluble or not? Lithium is group 1, so it is water soluble, and also you have nitrate. Lithium and nitrate, they both are water soluble, so this species is soluble. Now this is the first one is the complete the molecular equation. This first one is molecular equation. Now whatever the species that comes with AQ phase, you can break them down into the two ions. HNO3 comes with AQ, so you can break it down as H plus and NO3 minus. Lithium hydroxide comes with AQ, so you can break it as lithium plus and OH minus. Water coming with L, so we are not going to break it down, it stays as liquid form. And lithium nitrate comes with AQ, so you can break it down and as lithium plus and nitrate minus. So once you have that, you can figure out what your spectator ions are. Your spectator ions are going to be lithium and nitrate. So what is your real active equation? H plus combining with OH minus resulting in H2O. So this is going to be your net ionic equation. Now you might see something interesting. It really doesn't matter what your acid or what your base was. In the second example, your acid is nitric acid, your base is lithium hydroxide. In the first one, your acid is HCl and base is sodium hydroxide. No matter what your acid or base is, your net ionic equation is same for all acid-base equations. For all acid-base equations, your net ionic equation is always H plus OH minus resulting in water. Now let's try another exercise. Now pause this video for a moment and try it yourself. You have to write the reaction between sulfuric acid with sodium hydroxide. Now when you read a problem like this, you should be able to figure it out that it's an acid-base reaction. Why? You have hydroxide. Since you see hydroxide and hydroxide are generally bases, you know this is a base, and this already says it's an acid. So it's an acid-base reaction. You should get water and a salt. It's a double displacement reaction. So pause the video and go ahead and write the equation. Alright, sulfuric acid, recall that this is one of the 6 strong acids. So you are required to know the 6 strong acid and sulfuric is one of them. The formula is H2SO4. Sulfates are usually soluble. There are few exceptions. Hydrogen is not the exception. So H2SO4 is water soluble. You can put AQ sign. Sodium hydroxide. Sodium is group 1. So if sodium is sitting with anything, those substances are water soluble. So you can put AQ. Your products. Since this is an acid-base reaction, it is a double displacement. So sodium will exchange the partner. Sodium is going to combine with sulfate, now making sodium sulfate. If you're wondering how you got Na2SO4, that is because sodium is group 1 making +1 charge and sulfate, this is a polyatomic anion and you're required to know the formula and the symbol, and from the charge neutrality you get sodium sulfate. And sodium is group 1 and because of that it's water soluble. So you can put AQ. And then product. In any acid-base reaction you always get water. So this is going to be in liquid form. Now if you write the complete ionic equation and net ionic equation again, you will find your net ionic equation as H plus OH minus getting H2O. But as for this question, it is only asking to write you the equation when the description is given. So this is how you get it.